Buenos días, mis estimados aprendices. El día de hoy vamos a discutir lo que es la resolución del Classwork número 2 de Pesos. Vamos a colocar Pin My Video. Vamos a configurar lo que es la pantalla. Y vamos a dar por iniciado pues la clase, ¿verdad? This is the Classwork, Physics Classwork number 2 solution. Just hold on a second. I'm looking for my masterboard markers. Yep, we got it. Hmm? Okay, this is going to be Physics 10th grade classwork number 2. Classwork number 2 solution. All right, let's going to check what is the solution from the classwork number 2. Hold on a second. Vamos a buscar aquí Physics, Google Classroom. Okay. In the first problem says a 2-kilogram mass, problem number 1. A 2 kilograms mass and 6 kilograms mass, 6 kilograms mass are connected by a light, by a light 30 centimeters bar. Period. The system is rotating. The system is rotating horizontally at 300 revolutions per second. Per minute, sorry. At 300 revolutions per minute. About an axis about an axis 10 centimeters from the 6 kilograms mass. Period. Okay, what is the moment of inertia? What is the moment of inertia about this axis? And the second question is, what is the rotational kinetic energy? Okay, this is the first problem. Se me cayó. For the problem number one. Mhm. Okay, the first thing that we must do, remember, at the beginning of the situation, the problem gave us a frequency given by 300 revolutions per minute. We must to change revolution per minute into radians per second. Remember the conversion units. One revolution by multiplying 2 pi radians. In 1 minute, it has 60 seconds. This is going to be the process to the conversions. We can cancel revolution with revolutions, minutes with minutes, and the answer will be given by radians per second. So let me multiply those values. I'm going to obtain one similar result. Okay. Mhm. We got 300 multiplied by, yeah, we have meaning 130. Okay. Oh, I totally forgot. Yeah, lo olvidé. Okay, 302, 2 pi and divided by 60, that will be 31.42. 31.42 radians per second. This, my dear students, when we're talking about the angular speed or the angular velocity, this is the process that we're supposed to use to transport the units. Now, if you wish, this is an optional step, you can create a picture of the problem because this is not a very body diagram. This is only a picture. When we have the two masses, okay, we can say this is going to be one mass. All right, that will be the 2 kilograms separator. And we have a support in this part of the problem connecting with another light bar. Okay. And we have another mass. According for the situation, the first separation between this point to another one, remember, it has between the distance between mass and mass 30 centimeters. But the problem says about the 16 units mass, there's a separation of 10 centimeters. In simple merely words, we got 0.10 meters located over here. And so this distance will be given by 0.20. And we have that distribution of the revolution for the system. So how are we going to calculate that moment of inertia? Because the system will be rotating in uniform speed. That means the system, we can consider like a circular hoop. For that reason, the moment of inertia in a circular hoop will be given by iota equals mass times square radius. Okay, but remember we have two masses. One of them is 2 kilograms. The other one will be 6 kilograms. And we have to looking for that iota for the total system. In simple merely words, we can multiply 2 kilograms by 0.20 meters elevated the second power plus the another mass that will be 6 kilograms multiplied by 0.10 meters elevated of the second power. So basically we got 0.20 second power times 2 in the first one will be 0.08 kilograms square meters. And the second one, 0.10 second power times 6, that will be 0.06 kilograms square meters. So the total moment of inertia will be given by 0.14 kilograms square meters. This is the answer for the first question. And the second question is, okay, because we have the moment of inertia, what will be then the kinetic energy? So the rotational kinetic energy, AK, will be given by 1/2 iota omega of the second power. Simple merely words, 1/2 parenthesis 0.14 kilograms square meters, and omega is 31.42 radians per second elevated at the second power. So the rotational kinetic energy in the stop will be given by 0.5 parenthesis 0.14 parenthesis 31.42 second power 69.11. 69.11 joules. This is going to be the solution set of the problem number 1. Please, you can construct, show the entire process. Don't give only 300 revolutions per minute equals 31.42. Well, how can we do that? Simplifying the expression using the conversion of the units, the right system, the picture, the problem, and the set. Yo lo miré 300 revoluciones y que me puso una revolución tanto, pero no me hizo el proceso. ¿Cómo lo llegó? Tiene que haberme lo mostrado. Tenía que haberme lo mostrado, probado cómo lo llegó. No sé si multiplicó, dividió, sumó, restó. Tiene que mostrarlo. Ay, yo no lo sabía. Ahí no lo vi. Él. Tiene que enseñarlo todito, todito, todito. No está igualito. All right. Después. Vamos a la segunda. Second problem. All right. A 8 kilograms mass, 8 kilograms mass. Writing this. Has a diameter of 60 centimeters. 60 centimeters and is rotating it's rotating at 600 revolutions per minute. Oh, mismo acá. Okay, period. What braking force must be applied tangentially to the disc if it is to stop rotating in 5 seconds. in 5 seconds. All right. Second problem. Just going to move the camera just a little bit to the right side. Remember, what is the first thing that we must to do? Change revolutions per minute in revolutions per second. So we have 600 revolutions per minute. 2 pi radians. We have a 1 revolution. And 1 minute has 60 seconds. So in this case, can we give him by 600 parentheses 2 pi divided by 60, 62.83. Radians per second. All right, this is obviously we're talking about the initial speed. That's the matter I was speaking. Okay, so this is by one hand. By the other hand, we're talking about the disk, and this disk, a solid disk, we have a moment of inertia. The moment of inertia can be calculated by the following formula. I mean, iota equals 1/2 mass square radius. I mean, will be 1/2 8 kilograms times the square radius. I mean 0.30 because the diameter is the double the radius, so the radius that will be the half. So iota will be given by 4 parentheses 0.30 elevated the second power. That will be given by 0.36 kilograms square meters. This is by one hand. All right. So remember, we need to, because this is going to be a breaking force. There's supposed to be a torque between these two parts, right? For that reason, we must calculate the torque. In torque, there's two ways we can calculate that situation. Multiplying the force times the radius or iota times alpha. We know what is the value from iota, but we don't know what is the value from alpha. The only thing that we know is the initial velocity, the final velocity, and we know the time. For that reason, we can calculate that value, the angular acceleration by the uniform rotation disk or the angular uniform movement. So given this formula, because the final velocity that will be 0 because come to stop, we can conclude the negative iota divided by the period of time, that will be the value from alpha. So that will be given by negative 62.83 radians per second divided by, okay, the period of time is 5 seconds. The value from alpha, that will be a negative value. Why negative? Because we're stopping. We're talking about stopping force. 62.83 divided by 5, that will be negative 12.57. Radians per second square. This is the value from alpha. And why is so important to looking for alpha? Because tau, or the torque, can be calculated multiplying by iota times alpha. I mean 0.36 kilograms square meters and alpha negative 12.57 radians per second square. So torque will be given by negative what? 0.36 times negative 12.57. That will be negative 4.53. That will be Newton per meter. But we are not looking for the value from torque. We are looking for the value from the force. And remember, torque can be given by the product between force times radius. And because we're looking for the force, tau divided by radius, that will be the force. In simple merely words, negative 4.53 newtons per meter divided by the radius is 0.30 meters, and we're going to obtain the detention force. Negative 4.53 divided by 0.3, that will be negative 15.1. That will be the value for the force. Okay, that was the solution set from the problem number 2. Do you have some questions with this part? No? All right then. Let's solving the problem number 3. If someone wants to take a picture and send by the bots WhatsApp group, please take a picture of the first 2 problems. Tarea de. Es tarea, no es classwork. Lo grapó. Millón de mi agüita. All right, let's do it. The problem number 3. Si alguien le quiere tomar foto, por favor, y mandarlo al grupo de WhatsApp, el primero 1 y 2. Sería bueno. Problem number 3. In the problem number 3 says, okay, a wheel of radius 2 feet. Tómale foto ahí con confianza. A wheel radius 2 feet, sorry. ¿A dónde? Has a radius, oh, sorry, has a moment of inertia. Has a moment of inertia of 8.2 slug feet square. Slug feet square, period. A constant force, of 12 pounds, acts tangentially at the edge of the wheel. At the edge of the wheel that initially at rest. Period. What is the angular acceleration? And the second question is, how much work was done? has done, was done. And the third question is, what horsepower was developed? Horsepower. Well, starting rest in 5 seconds over here. In 5 seconds. And what is the angular acceleration? Well, okay. All right. The first thing that we can handle is in this kind of situation, we can try to looking for what will be the torque. Remember, torque can be given by the product between force times radius. Okay, what is the force? 12 pounds. And the radius, that's supposed to be 2 feet. And tau, that will be given by 24 pounds feet. This is the first thing we can make. The second step, we can try to looking for what will be the angular acceleration. Remember, torque, that will be given by iota times alpha. So alpha will be given torque divided by iota. Okay, and alpha can be given by, okay, the torque, that will be 24 pounds feet. And iota, that will be given by 8.2 slug feet square. So the value from alpha, let's going to divide the situation. That will be 24 divided by 8.2. That will be 2.93. 2.93 radians per second square. And you're going to ask me, okay, mister, if this situation, why is so important looking for alpha? Well, looking for alpha, we have two ways to solve this the problem. The first one, we can calculate the work in two ways. The definition of work in torque can be calculated multiplying by tau times theta, or also we can try to looking for the kinetic energy, and that will be also the work. So, 8.2 dice aquí. No, 8.2 dice acá, vamos a ver. 24 entre 8.2, correcto. 2.93. Ah, slug. Una S, slug. Por eso es. So, what are we going to do? Well, simple. If you really want to work with the kinetic energy, well, actually, the final kinetic and the final speed, right, can be given by the initial speed plus alpha period time. Remember, initial is at rest. So that reason, this value will be given 0. So the final angular velocity will be given by alpha times period of time. Okay, so alpha will be given by 2.93 radians per second square. And the period of time, remember, is 5 seconds. And we can try to looking for the final angular speed. All right, 14.65 radians per second. Okay, and we can try to calculate the kinetic energy that will be given by another way of saying the work. I mean, the kinetic energy will be given 1/2 iota omega, the second power. And iota, is 8.2 slug feet square, and omega 14.65 radians per second at the second power. So the kinetic energy will be, ¿cuánto? 120.3. Okay. All right, joules. And because we are looking for what will be the work, the power. Remember, power will be given by work divided by time. So that work will be given by 120.13 joules divided by the period of time is 5 seconds. So the power 120.13, 24.03. That will be watts. That's enough. Okay. We have 2 minutes left. So in the next class, we're going to finish with the problem number 4. Okay, guys, thank you so much for your attendance. Have a great, wonderful day. See you tomorrow in God wills. Take care of yourself. Bye-bye. So long. Take care of yourself.